All right, so let's go over this worksheet. In the diagram below, two parallel lines intersect circle O at points A, B, C, and D with the measure of arc AB equal to x plus 20, the measure of arc DC equal to 2x minus 20, and they want us to find the measure of arc AB. So the first thing to notice is that these two lines are parallel. What that means is that if the two lines are parallel, the arcs that they're intersecting are equal. And what that means is that I can take these two expressions, 2x minus 20 and x plus 20, and since the two arcs are equal, I can set them equal to each other. Finally, let's solve it. I'll take away x from both sides. I'm left with x minus 20 equals 20. I can add 20 to both sides, and I'm left with x is equal to 40. But it wanted us to find the measure of arc AB. Well, that means since arc AB is x plus 20, and I know that x is 40, well, 40 plus 20 is equal to 60, and that gives us the measure of arc AB. All right, next, I've got the second question. In the accompanying diagram, just the diagram that's with this, line PO and PS, that's PQ and PS are tangents drawn to circle O, and chord OS is drawn. QS again, QS is drawn. Yes. If the measure of angle P is equal to 40 degrees, what is the measure of angle PQS? All right, so I've got that this angle here is 40, and I want to find this angle over here. Well, since I know that I've got two tangents here, that means, and I'm going to label these two arcs out, I'll label this arc as arc A for major arc, and I'll label this arc over here as arc I for the minor arc. I know that the measure of this angle is equal to arc A minus arc I divided by 2. So 40 is equal to A minus I divided by 2. I've got a problem though, because this is one equation with two variables. So I need to find another equation that I can use. Well, the next equation is, since these are the only two arcs in this circle, I know that arc A plus arc I are going to add up to be 360. Well, now I've got two equations for two variables. I can solve this. So I've got 40 is equal to A minus I divided by 2, and that A plus I is equal to 360. Well, I'm going to start by isolating one variable so that I can substitute. Isolating meaning just to get it by itself. I'm going to get this A by itself by subtracting I from both sides. And I find that A is equal to 360 minus I. Once I have that, I know that I can just take this and plug it into my A in the other equation, substitute it in, so I only have one variable. I'm left with 40 is equal to, instead of A now, 360 minus I all over 2. If I keep rewriting this, I get that 40 is equal to 360 minus 2I over 2. I can multiply both sides by 2 to get rid of this 2 on the bottom. I've got 80 is equal to 360 minus 2I. So I'll take away 360 from both sides. 80 minus 360, I believe, is negative 200. And 80 and Yep. And that's equal to negative 2i. So next, I'm going to divide by negative 2 on both sides. These cancel out the negatives, and I'm left with 140 is equal to I. Now I found the measure of this arc over here. It's 140. If I want, I could use that to find the measure of arc A, but let's see if I even need to do that. Well, they want me to find the measure of angle PQS. PQS. Well, I don't even need the measure of arc A because PQS is an inscribed angle that intersects arc I right over here. And since it's an inscribed angle, I just know that the measure of angle PQS is equal to 1/2 of the measure of arc I, which we just found was 140. So that means that it's equal to 1/2 of 140, which is equal to 70. And we found our missing angle. All right, next question. I've got that the measure, and let me fix this so the camera can see the bottom questions a little better. I've got question C here. In the accompanying diagram, line AB and CD are chords of the circle and intersect at E. If AE is 10, EB is 9, and CE is 6, they want us to find DE. Well, you need to remember that if I have two chords intersecting, they make two similar triangles, where I've got a similar side with that similar side right over there. I'm doing just squiggles as my hash marks. This similar side matches with that similar side. And finally, this similar side matches with this similar side. So, just by following that, I can then just set up the equation 10 over 6, the smaller one, over this one over here, and then that's equal to x over 9. Now I pause for a second there because it looks like this should be smaller, but you can't assume based on a diagram that doesn't say it's to scale. So I'm just going to cross multiply on both sides. I've got that 10 times 9 is equal to 6x, which is 90 is equal to 6x. And if I divide both sides by 6, I find that 90 divided by 6 is 15, I believe. And so 15 is equal to x, and that's all that they were asking for. All right, question D. In the accompanying diagram of circle O, secant AC and CD intersect at point C. If the measure of angle ACD is 12 and the measure of arc BE is 30, find the measure of arc AD. Well, again, I've got my point outside of the circle, so that means that this 12 is just equal to my larger arc minus my smaller arc divided by 2. So that's equal to arc AD minus 30 all divided by 2. And now I can just solve it like an algebra equation. I'll multiply both sides by 2. I find that 2 times 12 is 24, which is equal to arc AD minus 30. I can add 30 to both sides, and that gets me that 54 is the measure of arc AD. All right, final question on this side. We need to explain the difference between area and volume. Well, area measures two-dimensional space, which means that it just measures how many boxes I can fit, how many squares I can fit inside of something that's just flat in 2 dimensions, where volume measures 3 dimensions, like a box, and it's how many cubes can fit inside that box. And that's all that it is. All right, let's move on to the next side. So this next side just asks you to write down the formulas for the volumes of the following solids. Well, for a general prism, it's always just going to be the area of your base times your height. For a pyramid, that is equal to your base, the area of your base, times your height, times, I believe it's 1/3. Let me just check to make sure I don't have that wrong. Yep, that is correct. So it is 1/3 times the area of your base times your height. A cylinder is the same thing. It's just the area of your base times your height, but you need to remember that the area of your base for a cylinder is pi r squared, and then times the height. A cone is the same thing as a pyramid is, except with a circle. So it is, again, 1/3 times the area of your base times your height. But since a cone has a circle at the bottom, it's usually 1/3 times pi r squared times your height. And finally, a sphere is equal to 4/3 times pi and your radius cubed. Now that's it. All right, final few questions before we end it. Went too far down. All right. As shown in the accompanying diagram, the length, width, and height of Richard's fish tank are 24, 16, and 18 inches, respectively. Richard is filling his tank with water from a hose at the rate of 500 cubic inches per minute, and the 16 inches, 18 inches, and 24. How long will it take to the nearest minute to fill to a depth of only 15 inches? So we need to be really careful here. They're asking about me wanting to go only 15 inches high. So even though the height of it is 18, I actually only want to find the volume up to that 15 inches over there. So I'll start by finding volume. Well, that's just going to be 15 times 16 times 24, because I'm just finding the area of my base, which is 16 times 24, and then times that height, which is 15. That's the height we're interested in. If I multiply those three in my calculator, I'm not going to do that one in my head. That is 15 times 16 times 24 is 5,760 inches cubed, because I had inches times inches times inches. So now, if it fills 500 cubic inches per minute, how many minutes will it take? How long will it take to the nearest minute to fill up this much? So if I do 500 and then 500 more and then 500 more, I can keep going until I get to 5,760. So I could do that and then just say, all right, 500 times how many minutes is going to get me 5,760. Or I can just realize, and this is going to get me there anyways, that I'm just trying to see how many 500s fit into this, which I can solve by dividing. So here you'll see with the algebra, I'll end up dividing anyways. I'm going to find out that the number of minutes is equal to 5,760 divided by 500. 5,760 divided by 500, which is 11.52 minutes. That's 11 and slightly more than a half minutes. So to the nearest minute, it's going to be 12 minutes because it's just more than half. Okay, now in the accompanying diagram, a rectangular container with the dimensions 10 inches by 15 inches by 20 inches is to be filled with water using a cylinder cup whose radius is 2 inches and the height is 5 inches. What is the maximum number of full cups of water that can be placed into this container without the water overflowing, without it going out of the container? Well, first let's find the volume of each of these. So I'm going to do the volume of my base, which is going to be the 15 times 20, and then times my height is 10. So 15 times 20 times 10 is equal to the volume of this guy right here. And that is 15 times 20 times 10 is 200 times 15, which is 3,000. 3,000 inches cubed. And the volume of my cylinder is going to be pi r squared times my height, which is 3.14. I'm just filling that in for pi, times my radius was 2, so 2 squared is 4, times my height is 5. And that is equal to 20 times 3.14, and the 20 comes from 4 times 5, so 4 times 5 times 3.14 is equal to 62.8 inches cubed. All right, I'm going to see how many times, if I do 62 times something, I want to get it as close as I can to 3,000. So 62.8 times x is going to get me to 3,000, because I want to see how many times I can put this cup into that container to make it exactly 3,000. So if I solve for that, I'll just divide both sides by 62.8, and I'm left with x is equal to, I'm not doing that one in my head either, 3,000 divided by 62.8 is 47.7 cups. Now, if I think about this, it's 47.7 cups makes it exactly 3,000. So at 47, it's not quite filled up, but at 48, it's overflowing. So how many cups can I put in without the container overflowing? It's just going to be 47 cups, because if I put in one more cup above that, that's going to be more than the amount that I said was going to make it equal to 3,000. So if I put in that 48th, it would start to spill out. Okay, final question. Jed bought a generator that will run for 2 hours on a liter of gas. So 2 hours per 1 liter. The gas tank on the generator is a rectangular prism with dimensions 20 by 15 by 10, as shown down here in this diagram. If Jed fills the tank with gas, how long will the generator run? And note, this is a super important note because I would not have known this either, 1,000 centimeters cubed is 1 liter, and that's convenient because we're working in centimeters. So I've got 20 times 15 times 10 centimeters, 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 and that is going to be equal to 20 times 15 times 10 is, oh, that's exactly what we had last time. This is 3,000 centimeters cubed, because I had centimeters times centimeters times centimeters. Now, this is equal to how many liters? 3,000 centimeter cubed? Well, 1,000 centimeters cubed is 1 liter, so 3,000 centimeters cubed is going to be 3 liters. So I've got 3 liters, and 1 liter gets me 2 hours. But now I have 3 liters, so I've got, if 1 gets me 2, 3 is going to get me, well, this is like similar triangles. So I can say, well, how did I get from 1 to 2? My scale factor is multiplying by 2. So the same thing, I'm going to multiply by 2 here, and I will get, this is 2 hours, I will get 6 hours if I fill up this gas tank. All right, that is it.